Hey everyone, and welcome to today's Explainer. You know, if you write React code, you've probably heard a million buzzwords thrown around, right? Things like virtual DOM, reconciliation, diffing algorithms, but honestly, how much of that is just jargon you kind of nod along to in stand-up meetings? Well, today we are officially replacing the buzzwords with a concrete, rock-solid mental model of the actual magic behind React. We're going to track the epic journey of a single line of code, literally from your text editor all the way to a glowing pixel on the screen. All right, let's dive right into this.
So here's our roadmap for today. We'll start with the great JSX solution, meet our true protagonist, the fiber tree, go inside the render phase, master the art of reconciliation, commit to the screen, and finally wrap up by busting some massive React myths.
Let me ask you something, and be honest here. What does React actually do? You sit down, you happily write your little h1 tags inside a JavaScript function, you hit save, and boom, your browser magically updates. But what is actually happening in between? I think most of us are just blindly trusting the black box, maybe copy-pasting a bit of Stack Overflow along the way. Well, it's time to rip open that box.
Section 1, the great JSX illusion. Okay, so this is step 1 of our hero's journey. Think about the code you write. It's this nice HTML-like syntax, nestled incredibly comfortably inside your JavaScript. But here's the reality check. Browsers do not speak JSX. They literally have no idea what to do with it. So a strict translator, usually Babel, steps in and converts your nice syntax into standard React create element calls. This function just spits out plain, super lightweight JavaScript objects. There are no real DOM nodes here, absolutely no HTML. It's just a JavaScript description of the UI you want. People casually call this the virtual DOM, but honestly, it's just the very beginning of the process.
Section 2, meet the fiber tree.
Now we're getting into the secret sauce of modern React. React doesn't just take those lightweight JavaScript objects and recklessly throw them at the screen. Instead, it builds this hyper-organized structure called a fiber tree. Every single component and HTML element gets its own fiber node. You can kind of think of a fiber node as React's ultimate micromanager. It remembers absolutely everything. It knows what type of component it is, its exact props, its state, who its siblings are, and precisely what changes need to be made.
Section 3. Inside the render phase.
I want you to picture React as this highly caffeinated manager locked inside a hidden underground lab. And here's the crucial, absolute mind-blowing point about this lab. Wait, what? Yeah, absolutely zero DOM updates happen here. Not a single real pixel is touched in the render phase. During this entire phase, React is completely in its own head. It's calculating, it's building out those fibers, it's executing your component functions, and it's preparing the work. It is 100% a background preparation process.
So you might be wondering, why do it this way? Well, it's because of Fiber's absolute biggest superpower, cooperative scheduling. Back in the old days, a massive app update would just freeze your entire screen until it finished doing all its computing. It was awful. But Fiber actually breaks rendering down into these tiny bite-sized units of work. If a user suddenly starts frantically mashing the keyboard in a search box, React can literally hit pause on rendering some massive low-priority background list. It immediately handles that high-priority typing so the UI feels incredibly snappy, and then it quietly resumes the background work when it has time. Honestly, it's a total game changer for performance.
Section 4. The art of reconciliation. All right, we have reached the climax of our story. A state update triggers, React reruns your component and generates new React elements. But instead of blindly pushing that to the screen, React builds a brand new work-in-progress fiber tree. Then it triggers this high-stakes showdown. React strictly compares the current fiber tree against the new work-in-progress fiber tree. Now pay close attention here. I didn't say it compares the virtual DOM to the real DOM. It strictly compares its own internal fiber trees to spot the exact differences. But doing a mathematically perfect comparison of massive trees, that is ridiculously expensive. So React uses some absolute genius heuristic rules. What I like to call its assumptions for survival. Rule 1. If the element type completely changes, like say a div suddenly turns into a span, React doesn't even bother comparing them. It just destroys the old subtree and builds a new one from scratch. Rule 2. If it's the exact same type, it just reuses the existing DOM node and only updates the props that changed. And Rule 3. It uses keys to quickly identify list items. Yep, this is exactly why React screams at you with those bright red console errors when you forget to add a key to a map function. It literally needs them so it doesn't get lost.
Through all of this diffing process, React obsessively compiles an internal effect list. Think of it as a hit list of exact mutations. Update this text node right here. Place this div over there. Delete that list item. But notice something really important. The screen remains entirely unchanged. Even at this late stage, the real browser DOM is completely untouched. The whole shebang is still happening safely inside memory.
Section 5. Committing to the screen.
Okay, so our caffeinated manager finally has the finalized blueprints. It leaves the hidden lab and hands this exact effect list over to the tired browser. This is the commit phase, and unlike the render phase we talked about earlier, this phase absolutely cannot pause. It has to be completely synchronous because, well, nobody wants to look at a half-updated, glitchy UI. React safely and minimally mutates only what was specifically on that list. It doesn't violently wipe the whole page, it surgically tweaks one single text node to say, "Hello Shivam," or maybe just adds one tiny class name.
Once React executes those minimal mutations, it simply steps back. Now, the browser rendering pipeline takes over. The browser recalculates the styles, figures out the layout and reflow, paints the pixels, and composites the layers. Because React only fed it the absolute bare minimum changes, the browser breathes a massive sigh of relief. It usually only has to repaint the strictly affected area. And finally, boom, the user sees the fully updated UI.
Section 6. Busting React Myths. Let's permanently cure your imposter syndrome with a rapid-fire myth-busting sequence, shall we? Myth number 1. The virtual DOM is a literal copy of the real DOM. Ha! False. As we just saw, it's simply a lightweight JavaScript description of the UI you desire. It has absolutely no intrinsic HTML properties whatsoever. Myth number 2. React compares the virtual DOM with the real DOM. Absolutely 100% false. React does not want to look at the slow real DOM if it doesn't have to. It strictly compares the old current fiber tree with the new work-in-progress fiber tree, entirely in memory. Myth number 3. If a component re-renders, the DOM re-renders. Nope. When a component re-renders, it simply means the JavaScript function executed again just to see if anything changed. If the resulting fiber tree is identical, the actual DOM is never touched. Myth number 4. The whole page refreshes when state updates. Honestly, this is probably the biggest misconception out there. React strictly updates only the changed DOM nodes. This is exactly why well-built React apps feel so fast and buttery smooth. All the heavy lifting is heavily localized. And finally, myth number 5. Fiber and reconciliation are two totally different things. No way! Fiber literally is React's modern reconciliation architecture. It is the engine driving the whole calculation and scheduling pipeline. Which brings us to our final core understanding for today. I want you to read this quote with me. React is fundamentally a scheduling and reconciliation engine that calculates minimal UI changes and efficiently updates the browser DOM. That right there is the real mental model. It isn't magic, folks. It's just incredibly well-organized JavaScript. So I'll leave you with this somewhat provocative thought to ponder the next time you open your editor. Are you actually writing a user interface? Or are you just submitting a list of highly prioritized requests to a caffeinated scheduling engine? Thanks so much for joining this explainer, and keep building.